In our first example, we're looking at PCl3. So this would be a molecule made of one phosphorus atom and 3 chlorine atoms. Our first step on our list, number 1, find the sum of valence electrons of all the atoms in the polyatomic ion or molecule. So this is just a molecule, not an ion, because there's no charge. So if we use the periodic table, we'll see that phosphorus in group 15 has 5 valence electrons. And then chlorine, now there are 3 of them, so we have to multiply 3 times. In this case, chlorine is in group 17, so it has 7 valence electrons each. So our total number of valence electrons here is 5 plus 21, that would be 26. And the reason this is important is because when atoms form molecules, it's the electrons that serve as the glue. It's those valence electrons that serve as the glue to hold the atom together. Alright, so in this case we've got to go into step 2. The central atom is the least electronegative element that isn't hydrogen. In this case, we would look on the periodic table. If you remember, the most electronegative element is fluorine. And so for the most part, the farther you get from fluorine, the less electronegative the element is. Also, one little hint is usually the first element is going to be the one that goes in the middle, unless it's hydrogen. So we'll put phosphorus in the middle of our structure, and we're going to surround it by the chlorines. Usually you put them on the top, bottom, left, and right. If there's only 3, we'll go with left, right, and bottom. And we're going to connect them now with a single bond. Each single bond, remember, represents a pair of electrons. So by drawing those 3 single bonds just now, that counts as 6 electrons. So I have just used up 6 of my total number of electrons. So I'm going to keep up with this up at the top, so I'll know how many electrons I still have to work with. Alright, so I've got 20 electrons left. That was step 2. Step 3, fill the octets of the outer atoms. Alright, that would be the chlorine. Remember, these outer atoms are more electronegative, so they get first dibs at the remaining electrons. I'm keeping up with my count. So far I've written 12 electrons. Alright, and so in red, I've just added 18 more electrons. So I'm going to subtract that from my tally. And I see I have 2 left. And that's going to take me to step 4, fill the octets of the central atom. Right now, phosphorus feels like it has 6 electrons. It's got 2 on the left, 2 on the bottom, and 2 on the right in the form of those single bonds. And so those last 2 electrons will be placed right there on the top of the phosphorus. I'm out of room, but if I subtract 2, now I'm down to 0. And that is a good thing. When you get down to 0 electrons, that means that you have used up all your electrons and you check to make sure that everything has an octet. In this case, yes, everything feels like it has an octet. Chlorine on the left has 6 of its own, plus it feels like it has 2 more in the form of that bond. Okay, the chlorine on the bottom feels like it has an octet because it's got 6 of its own plus 2 more which are shared. The chlorine on the right hand side, it's got 6 of its own plus those 2 that are shared. And then finally the phosphorus in the middle, okay, it's got 2 of its own, but it's sharing 6, so it gets to pretend like it has all of those. So in that way, all the atoms have achieved an octet. Another way to show this arrangement that you might see from time to time would be, instead of the lines, sometimes they'll use the dots and the pairs. And so there's chlorine's 7 valence electrons. There's this chlorine's 7 valence electrons. And here are the other chlorine's 7 valence electrons. Phosphorus, if you remember, was in group 15, so therefore it has 5 valence electrons. And when we do it this way, we're really focusing on those shared electrons. I'll move that one from chlorine over a little bit. There it is. And so in this way, you can really see how they have shared electrons, but they all feel like they have an octet. They're all surrounded by 8 electrons. And that's the most important thing for almost all atoms. The exception is if you ever have a hydrogen, and we'll see a hydrogen on the next example, hydrogen only needs 2 electrons instead of an octet because it's still in the first energy level.